Okay, I'm going to start with the intro slides, and then folks who are continuing to join, then you won't miss out on any of Pat's presentation. But we're really happy to have you all here for the Adaptation in Action webinar series. Today we have Pat Hamilton, who's the Manager of Sustainability Initiatives at the Science Museum of Minnesota. And he's going to talk about the climate change mitigation and adaptation potential of solar. We also have some upcoming events. So next month we have Fortified Homes program for our webinar. That's with Peter Brickwitty. He's the Assistant Commissioner of the Department of Commerce. And then another thing to think about for this fall is the Midwest Climate Resilience Conference. That's October 25th to the 27th in Duluth. And so registration is open for that right now. And so I encourage you to check that out. So you can register at MCRC, Midwest Climate Resilience Conference.umn.edu/register. And then just some reminders for today. So the webinar will end at 1 p.m. Today we might end up ending a little bit early, but we'll see. It depends on how many questions we get. And all the participants will be muted during the presentations. But we do have a Q&A at the end of the presentation. So you'll see on the Zoom bar, there's a Q&A option. Please put your questions in there. You can put your questions in at any time, and then we'll get to them at the end of the presentation. And then this webinar will also be recorded and posted on MCAP's YouTube channel at a later date. And then this screen is just showing you how to use that Q&A function. There's the Q&A button. You'll click that, and then you can type in your question, or you can upvote a question that you'd like to see answered if that's something you're interested in too. And then, like I said, we typically end about 1 p.m. and we'll definitely end by 1 p.m. So it's my pleasure to introduce our presenter, Patrick Hamilton. He's the Manager of Sustainability Initiatives at the Science Museum of Minnesota. We're also super lucky to have him on our advisory board at MCAP. And I had the pleasure of getting to talk to him more this past week at our advisory board meeting. Yeah, we'll have a survey at the end, but I will stop talking now and hand it over to Pat, and we can all listen to his awesome presentation. We're happy to have you here.
Thank you very much, Jamie. I want to thank you all for attending this webinar. And I want to thank the Minnesota Climate Adaptation Partnership for inviting me to do this webinar. As Jamie said, I'm Patrick Hamilton, and I'm the Manager of Sustainability Initiatives at the Science Museum of Minnesota. And I appreciate the opportunity to talk with you briefly about the climate change mitigation and adaptation potential of solar. And first of all, I just want to give a sort of 20,000 elevation look at the challenge that we're facing. We have two big tasks in front of us. We need to rapidly ramp up our mitigation of climate change by radically reducing the amount of greenhouse gases being emitted into the atmosphere in order to stave off the worst impacts of climate change. And at the same time, we need to speedily scale up our adaptation to the climate changes that are already underway and those that are anticipated. They are separate but equally comparable important tasks. When it comes to mitigation, there has been some very exciting developments in recent months here in Minnesota. Back in the winter, the Minnesota legislature and Governor Walz signed a bill mandating that electric utilities in the state achieve 100% carbon electricity generation by 2040. And so we're going to see significant expansion of solar energy in Minnesota and wind resources as well. So we're going to see significant growth in zero carbon energy production in Minnesota. But there's more to it than that. Because as we expand out solar energy in Minnesota, we're going to see significant economic and employment benefits as well. And much of this employment and economic activity having to do with solar will take place in rural areas because that's where we have by far the largest land resource for the application of solar. So with solar energy, we're going to get zero carbon energy, and we're going to get economic development and employment opportunities. And if we're intentional about seeding these solar developments with pollinator-friendly perennials, we'll see significant expansions of the habitat for pollinators and grassland wildlife here in Minnesota. And through photosynthesis, these plants that are seated underneath our solar arrays will extract some carbon dioxide from the atmosphere, convert it into carbohydrates, and some of that biomass will be underground. And we'll see carbon sequestration as part of the solar developments here in Minnesota. And more. Much of the solar development that we'll likely see in Minnesota will be in our rural areas, as I mentioned earlier. Large areas of Minnesota are devoted to row crop agriculture, corn and soybean. And so if we convert some of that row crop agriculture to solar with pollinator-friendly perennials underneath them, we'll be converting row crop areas, which at most have vegetation for a few months of the year, to a landscape with solar that has perennial vegetation 12 months of the year. And so we'll see significantly less wind and water erosion underneath these solar landscapes, and that will help further improve water quality in our rural areas. And we have seen significant expansion of solar in Minnesota in recent years. This is an aerial view of the North Star Solar Farm in Chisago County, north of the Twin Cities. It came online in 2017. It is 100 megawatts. It's a large installation. But in fact, it will be dwarfed by what Xcel Energy has proposed to do up in Sherburne County on the existing site of its Sherco 1, 2, and 3 coal-fired power plants, all of which will be decommissioned and offline by 2030. Last fall, Xcel Energy announced plans to put a 460 megawatt solar plant on that site. In May, just a month ago, Xcel Energy announced plans that 460 will be 710 megawatts, making it one of the largest solar plants in the country. And this makes sense. An industrial site that has been used to generate electricity for decades through the burning of coal will continue to generate electricity, but through the use of the sun instead. But in Minnesota, in the upper Midwest, and around the country, we're seeing some pushback against the development of large solar and other renewable installations in our rural areas because of concerns about how this is causing a substantial change in the landscapes that people have known and lived with for years. Now, quickly, when it comes to adaptation, Minnesota is seeing a number of changes in its climate, all of which are going to present adaptation challenges to us. But one in particular that I want to highlight today is extreme rainfall events. Now, these are not your garden variety thunderstorms with huge downpours. These are large-scale events. To qualify as an extreme rainfall event, a storm has to drop 6 inches of water or more over 1,000 square miles or greater over 24 hours or less. And it's not that these extreme events have never happened before, because we have observations going back into the 19th century of their occurrence, but there has been a startling increase in their prevalence in recent decades. And when these events occur early in the growing season, before our row crops of corn and soybean are able to layer out vegetation to protect the soil, we can see devastating amounts of soil erosion. So we need to rapidly scale up mitigation, and we need to rapidly scale up adaptation. Two separate tasks, but sometimes they can and should overlap, and we should look for opportunities when they do so, and I submit that solar is one of those. Now, here's a quick story. This is an aerial view of the south branch of the Whatnot River in south central Minnesota. Here at the Science Museum of Minnesota, we have a Department of Water and Climate Change, which runs the St. Croix Watershed Research Station, which is on the St. Croix River just south of Marina and St. Croix. For several decades, this research center has devoted itself to exploring the intersections between land use and water quality, both in Minnesota, across the United States, and elsewhere in the world. This particular research project was tasked with how to figure out ways in which we can reduce the large amounts of non-point source pollution that comes off of our agricultural landscapes, primarily because of the overwhelming prevalence of row crop agriculture devoted to corn and soybean. And so the experiment was, what if we were able to buffer a waterway with a landscape of pollinator-friendly perennials? So all those periwinkle colored polygons that you see are irregularly shaped fields adjacent to the south branch of the Watonwan River. And the question was, if these irregularly shaped fields, which, no, by the way, are difficult to cultivate, sometimes challenging to harvest, were instead put into some kind of perennial cover, what kinds of improvements could we see in water quality? And the computer modeling work said about a 60% gain, substantial, primarily through the reduction in sediment loading and the phosphorus associated with sediment loading. But the challenge is how to get these parcels of land converted to some kind of perennial vegetation. Because after all, even though they may be challenging to cultivate with large modern farming equipment, they still can produce profitable crops of corn and soybean. And this is where solar comes in. We're particularly interested in the idea of how solar could be this catalyst for helping to take the regularly shaped parcels of land, convert them into some kind of perennial vegetation and put solar on them, and allow farmers to square off their fields and dedicate their efforts under their most easily cultivated and most productive land. Now, what this would mean is that we would be able to better improve water quality, because while I mentioned earlier that solar can improve water quality, if put even out in the middle of a field, if we're actually able to put solar along waterways, we would see better water quality improvements. And by buffering our waterways with perennial vegetation, we would increase the resilience of those waterways to extreme rainfall events and reduce the hazards of flooding by downstream residents. But there is some concern about this because a lot of people have expressed concern about the idea of converting land, which is used to produce food, to a landscape that is instead being used to produce energy. But I submit that this is something that we've been doing for decades. Because if we look at all the corn grown in the United States, nearly 30% of it is used to produce ethanol. And by the way, only about 1.4% of all the corn grown in the United States is actually directly consumed by humans. So if we're going to be using our agricultural landscapes to produce energy, which is something that we've been doing for decades, maybe we can also look at ways that we can do that differently. So a quick story here. This is a community solar garden in South Central Dakota County, just south of downtown St. Paul. In the fall of 2017, the Science Museum of Minnesota signed up as a subscriber to this community solar garden. And I made a site visit to this garden in the summer of 2018 to actually physically see the site in person. And I was curious what had been the land use before this solar garden had been installed. And walking amongst the rows of solar panels, it was pretty obvious because you could see the corn stover left over from the last crop of corn taken off before the solar arrays were installed. So I was curious. A lot of the corn grown in Minnesota is used to produce ethanol, somewhere between 30 and 40%. So how does an acre used to grow corn compared to an acre of solar? So I promise you, this is your one and only multiple choice question of this webinar. But an acre devoted to producing solar electricity yields how much energy annually compared to the same acre devoted to growing corn for ethanol production? Is it A, 19% less, or B, the same amount? Because whether it's an acre of corn or an acre of solar, they're both exposed to the same amount of solar energy. Or C, 190% more, or D, 1900% more. Well, I've done the math and I've performed the calculations, and the answer is D, 1900 times more. So if we're going to use some of our agricultural landscapes to produce energy, why not use some of that land to produce far more energy? Now, some have said to me, this is not quite an apples to apples comparison, because if you grow an acre of corn, you harvest it, you deliver it to an ethanol plant to be converted into ethanol, there is a byproduct, dried distilled grains, which are then fed to cattle. So from an acre of corn, we can and we do get energy and we do get food. But I submit we can get the same with solar as well. Because if we take irregularly shaped fields, convert them to solar, seed them with pollinator-friendly perennials, we will eventually have to manage that vegetation. That vegetation can be managed mechanically by mowing it, or that vegetation can be managed by grazing it with sheep. And my colleagues at the St. Croix Watershed Research Station have done the calculations, and grazing sheep under solar panels compared to feeding dried distilled grains to cattle produces a comparable amount of meat per acre. Now, it would turn out it would be lamb instead of beef, but we would also get far more energy per acre. So by being more intentional about where we put solar on our rural landscapes, we would get better water quality improvements if we encourage that to take place along waterways and drainage ways as opposed to just out in the middle of open fields. And doing so would help buffer our waterways from extreme rainfall events. We'd still be able to get food production from that land through grazing. And I'd submit there's yet another opportunity. So I think that large-scale solar developments will be a reality in Minnesota going forward and across the Midwest in the United States. And particularly if you are an older landowner, maybe you're a farmer in your 60s and you're not going to be able to hand the farm off to someone younger than you and your family because there aren't any interested takers. If a solar developer comes to you and knocks on your door and asks if you're interested in selling all of your land to be converted into a solar development, you would be presented with an extremely lucrative opportunity, a hard one to resist, I imagine. Though your surrounding neighbors, landowners, would not see any of the financial benefit and would live with the visual consequences for decades. But if we encouraged more broadly distributed solar across our rural landscapes, and particularly using it to take an advantage of the retirement of irregularly shaped fields next to our waterways, we could more broadly distribute the solar benefits of solar to our various communities. Solar can prevent a tremendous amount of benefits to a wide array of audiences. But if we are more intentional about where we put solar on our rural landscapes, we get better water quality improvements, buffer our waterways from extreme rainfall events, still get meat production, and more broadly distribute the economic development benefits of the emerging clean energy economy. And I submit that this is very important because facing as we are the climate crisis and the mutual challenges of both mitigation and adaptation, we really do need an approach. And so that means to me is that people should be able to see opportunities for themselves, both economically and personally, to engage in mitigation and or adaptation. And I think solar presents very keen opportunities for us to do so. So we need to do mitigation and adaptation. And solar, I think, presents keen opportunities to realize both of them at the same time. And done right, we could achieve multiple benefits. We could achieve climate change mitigation and adaptation, increase habitat for biodiversity, and improve water quality, particularly in our rural landscapes. The pursuit of water quality, improvement of biodiversity, climate change mitigation, and adaptation are all efforts that we are currently engaged in here in Minnesota. It's just that we have not necessarily been thinking about how to get them all to overlap to the mutual benefit of each of them. And I submit that it's very important that we do so, because here we are. The future of Earth will be determined by human decision-making, either by default or by design, either by accident or by intention. So let's imagine, design, and realize the safer, more secure climate future that we all want. And I greatly appreciate the opportunity to engage with an audience committed to doing exactly that. So that's my story, and I appreciate your time and attention, and I'd be happy to respond to any questions or comments that may arise.
Thank you, Pat. That was awesome. We do have some questions that have come into the Q&A. And so for the first one, we have a question from Christopher Danner. Can you address the concern that Minnesota is not considered an ideal place for solar because of our location and sun exposure compared to places like Arizona? Is the ROI on solar still strong in places like Minnesota?
That's a great question. Clearly, some parts of the country have better resources, solar resources, than others. But actually, in Minnesota, right now, solar outcompetes the burning of coal to generate electricity, as does wind as well, which is why we've been seeing a lot of transition from utilities, including Xcel Energy and others, away from the burning of coal and the establishment of solar. And I think Minnesota actually has a better solar resource than we often imagine. We have very long hours of daylight in the summertime, and albeit winters are cold and daylight is short in the wintertime, but solar panels actually, their performance improves the colder that they get. So the harder they are, the less efficient they are converting sunlight into electricity. So I think in terms of both the solar resource we have and the fact that solar is already outcompeting the burning of coal to generate electricity, this is still a good place to invest in solar.
Oh, thank you. So we have a few more questions that have come in, which is great. And are there any concerns with putting solar energy along waterways? This is anonymous.
Not that I'm aware of. Solar panels they have no moving parts. The materials that are used to make them are very innocuous: glass, silica, some copper for wiring. And after that, they produce electricity solid state with no moving parts for 25, 30 years.
Well, thank you. And I've even seen they're putting solar panels that float on water bodies too, which is really cool. Another anonymous question, 710 megawatts MW per hour, or per how many hours or days is the solar plant producing? So how many hours or days is it producing that 710 megawatts?
Well, the 710 megawatts is the capacity of the solar farm. And so the actual number of megawatt hours that will be generated annually, I don't have that number. What I can tell you by comparison is that the Science Museum's subscription to a community solar garden in south central Minnesota, in Dakota County, it clearly generates more electricity in the summertime than it does in the wintertime. But it generates electricity every month of the year. And so I can't tell you how many megawatt hours 710 will generate annually, though it will be an enormous amount of electricity.
And we have a question from Mary Ann Steiner. She says, hi, Pat. I've noticed here in Western Pennsylvania, with both the gas and solar rush, that the energy industry is often way ahead of communities, making it hard for neighbors to talk to each other with contracts and non-disclosure clauses. Do you have examples of communities who have planned together for that broader community benefit?
Marianne, I think that's a great question, and I wish I could give you an example, but what I'm hoping is that a presentation like this and others gets communities talking and thinking about solar, not just as a form of energy, albeit that's an important function, but the opportunity for solar to achieve multiple benefits. And in order to achieve those multiple benefits, other parties need to be part of the conversation. So, and I would say that in recent years, solar has been approached primarily as just a way of generating clean electricity. And then we started seeding solar arrays with pollinator-friendly perennials, and we started to see like beehives associated with solar farms. And what I'm submitting is that if we broaden the conversation about solar, we could see it being a way of expanding and spreading out the benefits of the clean energy economy to not a winner-take-all scenario where a few landowners gain the lion's share, but many landowners have an opportunity to benefit. And that by being more intentional about where we place these solar arrays, that those who are concerned about water quality or groundwater protection can think about solar as a way of being able to do that economically.
I'm unmuted now. But thank you for that answer. That's great. And we have a few more actually. We have a question from Brett. Is the development of solar along waterways only conducive to rural areas, or can you see that same benefit in a more urban setting?
I think that there's certainly opportunities for solar in both rural and urban settings. I think that we're going to see more development of solar in rural areas simply because there is more, land is less expensive, candidly, and there is more open space with less obstacles for solar. I think that in rural areas, in urban areas, we'll see more solar going up on rooftops, parking lots, for example. And but I wouldn't rule out the opportunity for solar taking place along waterways in urban areas if it was seen as a way of helping to provide additional benefits. You know, I see it as an opportunity in rural areas because we have fields that often come up very close to the edges of waterways. So it's easy during rainfall events for soil and agricultural chemicals to wash from those fields and get to the waterways because they're so close. And if we were able to take some of that land out of row crop production and put it into solar, we would expand the buffering of those waterways from agricultural runoff. And the opportunity here that has bedeviled us for years is that the economics has never really worked out. How do we put these parcels of irregularly shaped land into perennial cover? Well, when solar can produce 19 times more energy than an acre of corn grown to and fermented into ethanol, it means that solar electricity can be a very lucrative crop that farmers and other rural landowners, I hope, will think about as a way of supplementing their income. In fact, gaining a source of guaranteed annual income, no matter what the weather does in terms of growing conditions.
Well, thank you. And we have another question from Mary. Thank you, Pat. Great presentation. Do you have suggestions for how mitigation educators in communities can help people understand the importance of insulating and sealing up their homes versus putting solar panels on their homes if they get electricity from a utility with zero carbon energy goals that are being achieved year over year and will be achieved by 2040?
So is the question, should people invest in the efficiency of their homes versus solar?
I think it's, yeah, how mitigation educators can help people understand, yeah, the importance of activities like insulating your home versus solar panels. Yeah.
Yeah. Well, as a homeowner, I know from firsthand experience that energy efficiency measures often are the most cost-effective ways of saving money. Solar, the price of solar over the last 20 years has plummeted, particularly over the last 10 years. But when I think it comes to saving money on energy as a homeowner, the first place to look is whether you're leaking energy, both allowing hot air in the summertime and warm air out in the wintertime. The return on investment and energy efficiency is usually superior to that of putting solar panels up on your roof, particularly since putting solar on a rural landscape where you're mounting them on the ground is an extremely cost-effective measure. Putting solar up on rooftops is more expensive because it involves more effort, more labor.
Perfect. And we have two more questions so far. Roberta asks, how do we manage waste from the panels after their useful life?
That's a great question, and it's something that's being worked on actively, because we're going to have a lot of panels that will have run out of their useful life. Now, the useful life of a solar panel is quite long because, as I mentioned earlier, there are no moving parts. The rule of thumb is typically a loss of performance of about 0.5% per year. So the degradation in the performance of solar panels is real, but it is extremely gradual, which means that a solar farm set up on a rural landscape will likely be profitably generating electricity for 25, 30 years, maybe even longer. But nonetheless, that still raises the question, what do we do with the panels after the fact? Now, as I mentioned earlier, they're quite inert in terms of the materials that are in them. Silica, glass, aluminum frame. So a number of those components are readily recyclable, like the glass and the aluminum. And I think work is ongoing to figure out how we fully capture the materials in those solar panels once they eventually come to the end of their useful life.
Well, thank you. We've had another question come in too. So we have two still to go. And this is from Laura. She asks, how will transmission work for those separated parcels?
That's a great question, and that's a challenging question and an important one, because a lot of the solar development that we've seen in our rural landscapes, particularly the explosion of community solar garden over the last decade, have taken place at the most easiest locations to put solar. For example, where we have the transmission lines and where we have substations. So it's a very easy connect to put the solars in a field immediately adjacent to a substation. I submit that if we haven't already in the near future, we will have developed those low-hanging fruit, and we'll need to look for further opportunities for how we put solar into locales that are not immediately adjacent to transmission lines and substations. And I would say it's comparable to the road network that we have here in Minnesota in the upper Midwest. We have township roads, county roads, state roads, all developed with a large part in mind of how do farmers and others get products from the rural landscape to customers, to urban consumers. And conversely, how do we get the inputs that farms need, agriculture, fertilizers, and fuels, to farms in order to produce the agricultural surpluses that we all depend on? I think that as farmers and others start thinking of solar as basically another kind of crop, creating electrons as opposed to, say, gallons of ethanol, we'll need to put in more thought about how we make our rural electrical system more robust so that farmers and other landowners can get their electronic crop to market. And also, we want to encourage the electrification of agriculture, just as we're encouraging the electrification of buildings and urban areas and transportation. I think there's enormous potential for the electrification of agricultural equipment. And that will need us to think about how we upgrade our electrical distribution and transmission in our rural areas.
Well, thank you. And we have another question now from Mary Ann. She asks, we have been having these kinds of conversations in our rural communities and are finding people are skeptical that we can shift our system in the time required to make a difference. Skeptical about who benefits and don't realize how much the sector is already growing. It's great to have the graphs to show the relative values for energy, jobs, and other products outcomes from this presentation. So.
Thank you very much, Mary Ann, because I know that you're working hard on this, and anything I can do to help you advance your work, please let me know.
And then we have from Carl, he shared some infographics that help explain differences between capacity and energy generation and different terminology, but not a question. So that might be, oh, is there one here at the bottom of my screen? Oh, Mary Ann says she'll be calling. So, but, and I think that's set all our questions. Lauren, can you see any more?
There might be one more at the very bottom from an anonymous attendee. Looks like it says, how much can landowners earn with solar electricity, corn, or other agricultural commodities over the same area? If the price of solar is low, getting lower, is there really a financial incentive for landowners to make the change?
It's a good question, and let me clarify. The cost of the solar panels have dropped precipitously in recent years, and also the cost of installing them, particularly in rural areas, has dropped as we've gotten companies that have had more experience putting in larger arrays. The value of the electricity, however, is high and continues to increase. So I think that the economics is actually continuing to improve, where the cost of installing solar has been trending downward, and the value of the crop, the electricity generated by the panels, has actually been going up. So I think that the economics are favorable and are continuing to move in a more favorable direction for putting solar on our rural landscapes. using solar as an opportunity for landowners to supplement their incomes as a way of not having to. What I like about this idea of using irregularly shaped fields for solar is that it allows farmers to square off and use their best lands most efficiently. And it allows them to take a parcel of land out of row crop production and put it into a use that can produce even more income than what they were getting raising corn and soybean, and an income that would be guaranteed year after year, no matter what the weather brings in terms of drought or hail or rain as they try to grow crops of corn and soybean. So I think it's a way of improving the economic security of rural landowners, particularly farmers.
Pat, you're winning the contest for question. We've got a great discussion going. So there's 2 more questions that have popped up. Do you have an idea? This is from Anonymous. Do you have an idea of the indirect cost of converting fields? The time a producer needs to put into paperwork, logistics, time and resources, prepping the field, etc.?
That's a great question. And usually all of that work is done by the solar developer. And so the solar developers have become quite adept at figuring out how they would lay out solar on the field, how they'll be installed, how to then seed it afterwards with pollinator-friendly perennials. So I'm not sure that's something that a landowner or a farmer needs to concern themselves with. I mean, they should certainly ask the questions and make sure that they get the outcome that they want. But I don't think that they necessarily have to think that they are the ones that are doing the work. They are signing an agreement to have a contractor come in and do a project for them.
Well, thank you. And okay, we have another question from Mary. Do you imagine transmission lines in rural areas going underground versus overhead to help prevent damage during more frequent storms, or is that too expensive?
That's a great question, and I wish I knew the answer. I think that it certainly is an option. You know, if you drive through any suburban housing development, you don't see any overhead distribution lines. It's all underground. There are pros and cons to either approach, and I would leave it up to experts and on perhaps a case-by-case basis to decide what would be the best way of moving the electrons from a new community, from a new solar farm to market.
Well, thank you. And we just have 2 enthusiastic comments, one from Laura and one from, both from Laura. Diversification and hedging, she says. So, but we still have a little bit more time if anyone has some questions come up. But Pat, you've done a great job fielding a lot of questions. Like I said, I think you've gotten the most discussion so far, so.
Well, it's been fun. I appreciate people's curiosity and hanging on and submitting the questions in the comments. And I would just like everyone to know that if you want to explore any of this in more detail with me, you are more than happy to reach out. I think I had my email on the anyway. It's phamilton@smm.org.
Well, thank you.
Feel free to follow up if there's anything more that you want to explore with me.
Well,
because I'm not an expert in this area, but I am an enthusiastic advocate for how we transition to the clean energy economy as quickly as possible, with as many people benefiting as possible. And I think that this is an extremely important opportunity for our rural communities.
Well, thank you. And Mary says, thank you, very helpful. We've got one more question that popped in, which is, are there any instances of above ground transmission similar to pipelines, so no overhead wires, but not underground?
Well, the community solar gardens that I have visited to date have all been connected above ground to nearby substations. Doesn't mean that it can't be done underground, because certainly the technology exists to do it either above ground or below ground.
And Marianne very helpfully answered helped answer the anonymous question of, I do think the question about what a coal or gas plant produces compared to solar or wind actual use megawatts, that would be helpful. And then Marianne followed up and says, I will just say that people in rural Pennsylvania are really interested in these conversations and have little opportunity to have them. So if we all go out and chat with people, it is helpful. Thank you.
Absolutely. Yep. Yeah. And I encourage the conversation to be broad-based. You know, there are state agencies and there are nonprofits that are very focused on water quality. And there are state agencies and nonprofits that are very concerned about biodiversity. And there's state agencies and nonprofits very concerned about rural economic development. And what I'd love to see is all these interests having a conversation about how the transition to a clean energy economy, especially solar, can help them get the gains that they've been struggling to realize for years.
Well, thank you so much, Pat. I'm just gonna wrap up with a few more slides to close the webinar. If more questions do come up, we may have time to squeeze them in, or as Pat said, feel free to follow up with him. Or you can also give us an email as well, and we can forward that along to him as well. But if you're curious about, I should go back one. So we have a brief survey, and Lauren, are you able to pull up the poll for that?
Yep, I can launch it right now when you're ready.
Oh, thank you. So this is just a survey to gather some of your feedback. We really take it seriously and it helps us improve our webinars. We're hoping to keep planning for more webinars in the future so we can have great speakers like Pat. So if you don't mind filling that out, that would be wonderful. There's a comment from Marianne that says, good point, Pat. Getting people together is amazing and essential. Thanks for the great talk. I echo that. Thank you, Pat, for the great talk. And so as you're filling out that, if you're curious about Minnesota climate news, here's a QR code that you can use to go to check out our website. You can also follow the link at the bottom, z.umn.edu/MCAP updates. And thank you so much for attending, and thank you for the great discussion. It was a pleasure to be here and to have Pat talk about such an important topic, and I got to learn a lot too, so I really appreciate it. And then I think that's my last slide. But feel free to reach out to us anytime. You can contact us through our website, www.climate.umn.edu, or you can check out or you can reach out to Pat as well. I think your contact might be on our website under the advisory board as well. So you
Yes.
can,
yeah.
Oh. Okay. Well, if there's no other questions, then we'll let you all go, and if depending on where you are, enjoy the sunshine. But thank you so much again, Pat, for your wonderful presentation. And yeah, I've been waiting anxiously for this presentation, so I really enjoyed it. Thank you.
Thank you all.